it's been very much an international day today with Peter this morning and the Starship and so on. Now pleased to welcome Fish about AMSAT-NA and what's going on in the States, which should be very interesting and a most important session of this. Burns.
Okay, thanks. Hi, can everyone hear me okay now? Just okay, very good. I wanted to check, and I should be able to share, I guess. Let's just see how this works. Share. Hopefully you can see that now. And
yes, we can. I enabled sharing earlier.
There we go. Okay. Someday, Zoom and Microsoft are going to get together so that one can expand the PowerPoint slide at the same time that you can see everything on Zoom. So anyway, I also want to. There we go. Can't do this ahead of time because you just don't know what's going to show. Anyway, welcome. Thanks everybody for listening. I'm Burns Fisher. My call is Whiskey Bravo 1 Foxtrot Juliet. I'm a life member of AMSAT North America, and I volunteer for AMSAT as the lead flight software developer for our Gulf satellites. This software is also the basis of the software that's in LTM radio sets that we provide to university partners, our upcoming Fox satellites, Fox Plus satellites, I should say, and the PACSAT payload. And all these I'll be talking a little bit about later. I want to talk in general about a few things. So the kind of general subject is stuff that AMSAT-NA is doing, but I want to talk about the Gulf project. You've probably heard about the Gulf project for many years. It's been, shall we say, long running, but things are moving along more now. The Fox Plus program, a kind of revitalized program called Ascent, which I will translate that acronym for you as soon as I remember it myself. The LTM program, which had a launch in July, and I'll also point out a few current satellites that are available for use. And speaking of a launch in July, boy, that was exciting to see today. I didn't tune in time to see the launch and the catch of the first stage of SpaceX, but I saw the landing of the Starship, or quote land. I guess it's more like the oceaning of the Starship, and that was pretty cool. So I'm glad you all got a chance to see it as well. Let me just bring up before I start, I wanted to mention a few anniversaries that are close to today. AMSAT-UK's FunCube 1 11th anniversary in orbit is coming up next month, I believe. You might recognize this picture that I put on here as the NEPA rocket launching FunCube. So that was pretty cool. Special to me, since it's the first satellite I worked on, is AMSAT-NA's Fox 1A. And its 9th anniversary was last week. For both of us, exciting moments to hear each of these satellites for the first time. And of course, we have the grand old man of satellites, AO7, 50 years and still operating when it's in the sun. Now, I can mention these anniversaries, but of course, if you do the probability calculations, given that there are 122 Oscars, the probability of some anniversary for one of them coming today is about 28%. So maybe it's not as exciting as I thought it was. So let's go on with the Golf T program. Golf stands for Greater Orbit, Larger Footprint. Everybody wants a higher orbit. We would love to have more higher orbits. The Green Cube managed to get one And that was a wonderful thing. We had somebody here in the eastern United States that was able to get their work to all states by satellite certificate by reaching Hawaii, which is way off several thousand miles to the west of the western United States by way of Green Cube. So that's a nice thing. But we'd love to have more satellites in higher orbits. Uh, Unfortunately, the regulatory environment in the United States makes higher orbits very difficult for small, non-commercial organizations like us. But we have one group of volunteers that's trying to work on that, figure out what we need to do in order to get to a higher orbit regulatory wise. But in the meantime, Golf T is moving ahead to launch into low Earth orbit. Its plan is to develop technologies that we do need, that we'll need in the satellite itself for higher orbits. Our current thought and hope is to launch in 2026, but we are not manifested on a flight yet. So again, Golf T's goal is to gain experience with and develop technologies to test in low orbit that will be needed for high orbit. So let me talk about the Golf T satellite and a few of those technologies. First off, there's a 10 gigahertz downlink test and several microwave uplinks. And why do you need microwave for high orbit? It's because in the higher orbits, you need some sort of a directed antenna. And a directed antenna is going to be huge for the usual 2 meter, 70 centimeter sort of thing. So we want to have a microwave downlink that we can use much smaller antennas on. Golf T will be fully attitude stabilized, and the reason we want to do that is to allow deployable solar panels and get more power. The panels will deploy, and they're all pointed in one direction. So you want the satellite pointed towards the sun. And similarly, the microwave antenna wants to be directed towards the Earth. Now, you can't always do both at the same time, but at least we can move back and forth between Earth pointing and sun pointing. We also have a redundant IHU onboard computer, redundant command receivers, redundant telemetry transmitters, and so on. But we will also have a traditional 30 kilohertz VU linear transponder. So I mentioned that we've been talking about this for years. There have been a huge number of delays. A key member of our team and a good friend became a silent key. Bob Davis, if you ever know KF4 KSS, died in the middle of bringing this whole thing up and in the middle of the pandemic. So, it's just a horrible problem and a horrible situation for all of us. The supply chain problem that the pandemic caused for us, the ADCS and power system supplier that we were planning to use couldn't deliver. I don't know if they're actually still operating or not. They just had such a problem with the pandemic. And of course, delays also mean parts that are going end of life. So we need new designs. We need new volunteers. And with the new volunteers, we need a new training regimen. So all of this stuff has delayed golf enormously. But we do have the program going ahead now with many new volunteers. So let me show you what Golf T is supposed to look like. This is a diagram, and it's from over a year ago. So things have changed a little bit. And in addition, this isn't quite to scale. But to give you a general idea, this is sort of what it will look like. 3U, of course, means the satellite is about 10 centimeters in width and depth, about 30 centimeters long. Now, I don't have to explain this to you guys. For U.S. audiences, I have to say 4 inches by a foot. So it's nice to be able to stick with metric. You can see there's a sort of standard longitudinal stack. I'm going to try to move my mouse, which I think you can see here. This is this is a standard stack. It's very much like our Fox um, stacks with a processor, an RxTX transmitter receiver, command receiver. But now we've added on some experiments, and we've added on this redundant processor system, as well as the redundant, we call it the DCT, the transmitter receiver. Down here is the EDIS. We are using an EDIS E310 to do the microwave work. And over here is the attitude control system, the ADCS, along with the power system and a few other odds and ends like the microwave, the power amplifier. So I just will show you a little bit more because we've been doing a lot of work. The ADCS in particular has upgraded from Gen 1 to Gen 2, and I'll be talking a little bit more about that. But we've also been able to generate appropriate models of this. So our mechanical designer recently got all kinds of STL files of the design, and he got them pieced correctly so he can build a 3D printed model of the satellite. So you can see this is very similar, except it's an actual photograph. And you can also see that the ACS looks quite a lot different down here. And there are a number of different boards here that have changed a little bit in the last year. But this is much closer to what we're working on now, although there is some tweaking continuing. Come on, there we go. So this is what Gulf T actually looks like right now. This is my shack. And we call this a flat sat for obvious reasons. You probably do the same thing on your satellites. Out of sight to the right. Whoops. There we go. Out of sight to the right is the EDIS 310 transmitter and receiver. That'll be used to receive the microwave uplink and will be connected to a 10 gigahertz upshifter and power amplifier for the 10 gigahertz downlink. Right. There we go. In the right, and you can see it there in circled in red, is a stack consisting of the command receiver, a 30 gigahertz linear transponder, UHF telemetry transmitter, as well as the 2 onboard computers. 2 of those boards are legacy fallbacks in case the new stuff doesn't work. 1 onboard processor and 1 command receiver. We, for future Golf Ts, may not need to use that. We will use the RxTX most likely because that contains the linear transponder. Now the red circle has moved. In the center with that gray cable connecting it is what we call the central interface unit. It's the central connection point for lots of satellite pieces, including the longitudinal stack, which you could see on the right. That's where the EDIS will connect in. That's where the antennas will, or the antenna release mechanisms will all connect in there, as well as the GPS, the power supply, and so on. So it's not terribly exciting in many ways, but it's really important. You can see a USB connector down there at the bottom. So that USB will be the umbilical connection for when the satellite is all put together into a 3U package. And that will be how we will access processors and everything else when it's packaged, but before it's placed into the launcher. On the front, on the left there, is the GNSS unit or GPS, circled in red. Behind that is the development model of the ADCS, and that should be circled in green. Yes, I can see it. There we go. Over here, the development model is just kind of a square box here, with this connection plugged into it with the cables going to it. And the things that are circled in blue, which are here and here, are development kits from the manufacturers of the ADCS and of the GNSS systems. They're pretty huge. They make it convenient for us to do testing at the moment. They're not going to fly. The GNSS system here is the only thing that's going to fly. That's pretty tiny. And the ADCS here will actually fit on the longitudinal stack as opposed to the transverse stack, which is here. Okay. So that's what the current system looks like on my bench. Of course, it doesn't give me much room for anything else. So let's look at a few of the individual pieces. This is the RTIHU, which stands for Radiation Tolerant Internal Housekeeping Unit, or we hope it's radiation tolerant. How this is made is it's got two processor chips, one here and one here. These are both automotive grade processors from TI, Texas Instruments. So they have a lot of redundant stuff in them. They have an EDAC, or error detecting and correcting memory system, parity buses, and actually within each one of these processors, there are redundant cores, and the cores are actually in lockstep with each other. And if something goes wrong, and they don't, they're continuously being compared. And if they don't compare correctly, an error flag gets raised. And on our board, the error flag causes us to switch from one processor chip to the other processor chip. So there's a lot of redundancy built into this thing. The two redundant board halves have two processor chips. I can point to the processor chips. I'm not sure I can actually figure out which of these devices is which. Besides the processor chips, it has a non-volatile memory chip called an MRAM. It has a command receiver and telemetry transmitter, and either one of these can double as the other. In other words, if one entire side fails, then that one chip, the command receiver transmitter, can do both. It has to switch back and forth between receiving and transmitting. But if there is a massive failure, we still have transmit and receive capability. What I can point to is in the middle here, these are bus switches. So the failed side of the RTIHU is kept off the satellite bus, or it doesn't even have to be failed. Only one of these sides is operating very much at one time, and that's the one that's connected to the satellite bus. So that's the RTIHU. The ADCS, the Attitude Determination and Control System, this picture is the Gen 1 version of what we plan to use as the ADCS system. We'll be using the Gen 2. You kind of saw the Gen 2 in that picture on my bench. It's not very interesting because it's the Gen 2 comes all enclosed. So this is more interesting. It would look fairly similar if you were able to disconnect the Gen 2, or sorry, take the outside off of the Gen 2 system. We are buying this from a company called CubeSpace in South Africa. I was in South Africa for another purpose this summer and was able to stop and talk with them and ask them some questions. So that was quite a fun thing to do. We hope this will work nicely. We're probably not going to use the star tracker that you can see on this picture. We're only going to have a sun and an earth tracker because we don't need that fine control. We currently just have a development model. The development model doesn't actually have all of the devices, the actuators and the sensors, but it does have the capability of talking to, over the communication buses, so that I can develop the software to communicate with it. We also have software that will simulate being in orbit and will simulate more of these devices. So we should be able to do a lot with the development system, even before we have the flight and engineering models of the full ADCS system. This is the CubeSpace Cube computer, the board that we got initially. But we do now have the Gen 2 version, which, as I said, is all enclosed and a lot less interesting to look at. We have it, I just last week got it connected to the satellite onboard computer, and I've been talking to it over a CAN bus. I2C will be coming as a backup, and we can also talk to it through a UART, that is a serial line interface, and I'm leaving that to be able to connect with a PC and their CubeSpace's testing software. I may have mentioned, I think I did mention that we were going to get a power system commercially, but that purchase fell through because of the pandemic. We got some new volunteers recently who were interested in designing and building it. So we said, sure, let's, the more we can design and build ourselves, the better off we are. We want to do that. So this is an early prototype of the MPPT. MPPT stands for Maximum Power Point Tracker. If you're not familiar with the way solar cells work, they give a different amount of maximum power depending not only on their temperature and the sun angle. I mean, it's not surprising that if the sun isn't directly at them, they're going to give less power. But the interesting thing that you need to do is to tweak the voltage and the current that you're pulling from them in order to maximize the power that they will give. And that's what the MPPT does. We also will, the same group of people is designing a battery management system to maximize the battery life and safety, and a power distribution system to provide the actual correct voltages within the satellite. So you can see there's a evaluation board for one of the processors right here, as well as the other stuff that they're going to test. This is, I believe, where some batteries are, some batteries are going to go. Sorry. So the current state for the Golf T is that we are going through preliminary design reviews. We actually did do the preliminary design review for the power system last Wednesday, and that came out pretty well. We had some questions, and the designers are going to answer the questions, and hopefully we had some good ideas that they can incorporate into their final design before their critical design review, which will be coming up probably mid next year or early next year. So you can see that we have a lot of prototype boards and a few boards that we would even say are engineering model level boards that are under test. And most of those boards are under test in the flat sat that you saw the picture of earlier. The space frame design is making good progress. Again, you can see that it's good enough that we could make 3D printed models of it. The next thing that the mechanical engineer fellow is going to do is to actually bend some metal and make metal models of it to make sure that all works. The deployable solar panels are also making good progress, and the metal tests, the metal bent metal, space frame design will allow us also to test out the solar panels. They've got to be able to fold up on that space frame and to unfold without breaking themselves. So that testing will be done. So being the software guy, I will tell you a lot of software has been done for years. Unfortunately, a lot of the software also requires talking to and commanding and sending down telemetry from new hardware that we're only just starting to get. So there is still a lot of software work to do, but the software that knows how to deal with 3 different processors and how to choose which processor it's going to use, how to collect telemetry from all 3 processors and have only the active processor send the telemetry. All that good stuff has been done for quite a few years. But there is still a lot of work to do in the software realm. Golf T has been accepted into the NASA CSLI, CubeSat Launch Initiative, and Alana, what does Alana stand for? Something educational launch of nanosatellites into that program. It is not manifested for a launch yet, but we've passed the hurdles through NASA to say, yes, we think that you belong in this program. And to be honest, 3 of our Foxes also did the same thing. They went through Alana, and that's how we got the launches. And the good news is the paperwork weight is approaching the weight of the satellite. So that means it's going to be ready to launch pretty soon, we hope. So as I think I mentioned briefly earlier, we hope we'll be ready to launch in 2026. We do have a lot of potential worries. And once we are manifested, the actual launch date is pretty much out of our control. Some of our satellites have waited a few weeks after the original specified date. Some have waited a few years after the original specified date. It all depends on the launch provider. NASA tends to use new launch providers to launch CSLI satellites, and new launch providers tend to have a lot of delays. So we'll talk a little bit about that in a minute for some of the other satellites. So that's the Golf T state. By the way, if anybody wants to ask any questions, do feel free. I don't know how it works with golf, but if someone can type into the Um, um,
Yeah, Burns, we usually leave questions till the end of the talk, if that's okay.
okay, yeah, absolutely. That's absolutely fine. Thanks. Sure. Okay, so Fox Plus. Now we've gone through Golf T. Fox Plus is a new program. Fox One, which was AO 85, 91, 92, and 95 was in there as well, and 102. Um, they were mostly FM satellites, which were, and especially those three were popular, but they have mostly failed now. They had NiCad batteries, and NiCad is supposed to be okay for lots of charge and discharge cycles, but the um, temperature thermal environment that we predicted was not what we actually saw according to our telemetry. So I think that's probably one reason that the batteries failed sooner than expected. AO91 is still operating, um, although I think there isn't enough voltage to run the processor. So we're not seeing any telemetry from it. I do see that there are some people that are still using it as a repeater. But AO91, when it is running, SO50 and any of the FM satellites are really crowded. Their FM is popular, and but since only one can use it at a time, that makes it more crowded. So we need more satellites quickly and soon. FMs are easy and inexpensive to use, lightweight equipment, easy to do remote operation, but more linears also reduce crowding. And so the point of Fox Plus is an attempt to be able to launch satellites that build on Fox One with some improvements, but also to be able to launch them relatively quickly. Um, we wanted to be able to just use Fox One with some slight upgrades, but so many of the components we found that we used in Fox One are obsolete and unobtainium, as we say. So they're just not the stuff to put in them isn't available. Not to mention, as I said before, our mechanical engineer from Fox One is a silent key, so we have to restart some of the mechanical work. So Fox Plus is both trying to recreate Fox One with new ideas and components, as well as using a subset of the golf boards, which are all being worked on currently, as well as purchasing some pieces whole. So the Fox Plus philosophy: build on Fox One, build on work done for golf. By the way, Fox Plus One can also flow back to golf. Fox Plus can flow back to golf. We want Fox Plus to be open source and access and all documents to be on GitHub or GitLab. There are a few that are NDA docs from purchased stuff that we can't make open, but we want to as much as possible. Why do we want it open? Because more grants are available and we avoid ITAR issues. Now, ITAR is unfortunately a US regulation called the International Traffic in Arms Regulation. Some parts of satellites might be considered armaments under the ITAR. So in Fox and Golf, we have to be careful only to have US persons, that means mostly citizens, working on them. Making everything open source takes advantage of a cutout in these regulations, so we aren't covered by it. And then, as I said, in addition, some grant sources require open source development, allowing us to apply for these grants. So between those two reasons, we want it to be as open as we possibly can. Notice that we still have to pay attention to other regulations called EAR, EAR, export administration regulations, if we actually export hardware. Luckily for us, low Earth orbit is not considered an export. But if we were, for example, to launch on, well, we can't launch on Ariane anymore, but if we were to launch on PSLV or any of the ESA launchers or anything like that, that would require export. So we'll probably mostly be launching on US launchers. Later Fox Plus satellites might well have more capabilities than are here. Fox Plus A is going to be just a 1U, magnetically stabilized. That is, it'll have a bar magnet in it that will attempt to follow the Earth's magnetic field. The space frame, power, solar panels, all purchased for speed and development. Later Fox Plus versions may be bigger and pull in work from Ascent, which we'll talk about in a minute. And that includes a new packet satellite payload. Think FalconSat, if you've had any experience with that. Actually, you might not have been able to use FalconSat in the UK, because I wasn't either. It was a fairly low inclination orbit. So the Fox Plus A status, we have a number of new volunteers. A system engineer are recruited. As of now, there's a meeting concurrently with the golf team, at least among members that are vetted for ITAR, because that meeting is considered ITAR. We do that though to get cross-fertilization and to help with onboarding of new volunteers. There's hardware on order. The antenna has arrived. The solar panels are going to arrive soon in the power supply. The preliminary status review is coming up, and that's actually a pre-PDR type of thing. It's just looking at what we need to do next. Optimistically, we might launch before Golf T. You know how that works. Yeah, that's what we would like, but it's probably not going to happen. This is being the first one of a new generation. Future Fox Pluses, B, C, and D, they're likely to be larger, a 3U size of CubeSat. That will allow for deployable solar panels, giving more power. More power gives more capabilities. And we can take advantage of Ascent and other new payloads. In fact, Fox Plus B is going to carry PACSAT. And I'll be talking about, I keep giving you these little hints that I'm going to talk about Ascent later. The LTM program is another AMSAT program. LTM is a set of boards that we make available to universities that want to do their own experiments. They want to do experiments, they want to do things in orbit, but they don't want to bother with all this radio stuff. They want to build something else. So we give them commanding and telemetry. When they're done, sometimes while they're operating, they agree to turn on an amateur radio linear transponder. The LTM consists of 3 boards, essentially identical to those that are going to be used in Fox Plus and as part of Golf. The RXTX is the receiver transmitter, the LIHU is the onboard computer, and the ICR is the improved command receiver. So 2 of these LTMs have flown so far. One is the University of Washington, HuskySat, that was several years ago, and the University of Maine, MESAT-1. And I have some slides on MESAT-1. We'll talk about that in more detail later. For those 2, we did a lot of customization. But if we want to keep supplying LTMs, We just don't have enough volunteers to customize every board set for every university. So starting with the next ones, we're going to try to do something different. We have created a generic interface control document. And it essentially says that we give the university some specific downlink channels of data channels, some digital, some analog, a few specific I2C devices, as well as the ability to send their own data as CAN packets, which they can define. We give them some specific commanding capabilities, and we give them the ability to send their own commands. But essentially, each one of these LTMs that we will give to a university is the same. And what they want to be different, they do themselves. We give them the capability of doing themselves. So we hope that will both get more linear transponders in orbit and save us volunteer time and handholding, if you wish. Oh, huh. I had to. Anyway, yes. The LTM, again, I guess we don't need this one because it says the same thing. But one of those LTMs is called AMSAT-1. That's our current university partner. They just launched last July, and this was a very long delay. It was a long delay because it launched on the Firefly launch vehicle. And Firefly is a brand new launch partner of NASA. Firefly had done a lot of testing, and they had a few failures. They want to get into the launch business, the quick launch business for the defense industry. So they had a few special launches for the Department of Defense. So anyway, this delayed actually literally 2 years, I think, from what was originally planned for AMSAT-1. But it finally launched. The launch went well. Things seem to be going well with the satellite. AMSAT-1's science mission is multispectral imaging of Maine estuaries. This is the point Maine is the northeastmost state of the United States, and there are a number of rivers going through Maine and emptying into the ocean. And that place where where the rivers meet the ocean is what they wanted to study. It does have the LTM amateur radio 30 kilohertz transponder. The telemetry is receivable by anyone using the newest version of FoxTelem, and that includes the science downlink. So if you want to receive telemetry from AMSAT-1, we appreciate it. Any telemetry is helpful. The current status of AMSAT-1, it's in orbit, it's transmitting telemetry. The linear transponder has been running for several weeks, but just yesterday, I think they turned it off. This is all still experimental, so they want to save the battery and check how the battery recharges and all that sort of stuff. The picture taking story is mixed. We do get picture data, but there's no image visible. And that may be because AMSAT Ops has been helping because of the launch delays meant the original students have graduated. Always a problem with universities. So Maine is trying to get new students to run the experiment. But in the meantime, AMSAT has no expertise in how that all works. Maine is trying to get new students and take over the science. The ASCENT program, now here's what it stands for: Advanced Satellite Communication and Exploration of New Technology. Our VPE, Jerry, is Vice President of Engineering, is really big into making acronyms. Think of it as R&D. The idea to develop new ideas that we don't have a specific satellite use for. In fact, the original Ascent program developed some concepts like the RTIHU, the microwave RF in golf, but it was largely oriented towards developing technology for a commercial partner. Anyway, Ascent went into hibernation for a while, but it's back now. Current Ascent projects. The 3U space frame with deployable solar panels is considered Ascent. It's partially funded by ARDC, Amateur Radio Digital Communications. Interesting story about how they got a lot of money to give out, which I won't spend any time now on. They are a private foundation existing to support amateur radio and digital communications. So thank you to ARDC. They're looking for projects to fund. They are not US limited, so feel free to consider them if you need money for something. This space frame is likely to be used for both Fox Plus and satellites for golf. More golf than Ascent, but it is open source. AMSAT developed some reaction wheels. Somebody wanted to do it, so we've developed it. This is still in the very early development stage. There's no software for them yet, but that's why it's an Ascent project. We're doing a homebrew microwave receiver transmitter to replace RX in future golf and later. And we have a just graduated Ascent project. There's a packet satellite for a packet store and forward. It's got four receivers. Here, AX5043 chips are the receivers. It's got a TMS 570 processor, and it's got a single AX5043 or transmitter. So it's packet store and forward, multiple uplink frequencies, and a multiplex downlink. So think of it as a mailbox and file distribution in the sky. Now that was developed under Ascent, but we're planning to fly it on a future Fox. So we no longer call it Ascent, but I'll still talk about it here. Here's the PacSat Proto, and I know I'm coming to the end of my time, Ian, so I'll try to go fast. PacSat prototype that you see here, which was designed to go with an evaluation board, which is the red board underneath it for the processor. Then we went to a PacSat prototype board, which is full prototype that has the processor on it and so on. Lots of software has been written, the onboard file system, packet receiver, packet transmitter software, telemetry downlink, and commanding. All this stuff is written on the old on the Proto 2. Currently working on a new board that will go on the Fox Plus. So I'm just going to very briefly talk about current AMSAT-related satellites that are in orbit. AO91 is there. You can see the frequencies. The batteries are very, very unhappy and getting worse. So we don't know how long that will last. There doesn't seem to be any telemetry coming now, but there are repeater ops. MO122, MESAT-1 was recently designated main Oscar 122. You can see the frequency for the transponder, the linear transponder. AO7 and AO27 still chugging along with some time constraints. And this picture, by the way, is the Dwinglo in the Netherlands PICAM radio telescope, which has been invaluable for receiving weak signals. They've been so wonderful to us, particularly receiving AO109, which has recently re-entered. But in the meantime, we got lots of telemetry from them. And you know about the ISS, I expect. I think you recently had some ISS contacts, but they do have a repeater that runs frequently, an APRS digipeater, And right now, again, I think you're aware of this. They are doing downlink of some slow scan TV signals. And occasionally, instead of a repeater, you'll find a live astronaut. That actually happened to me once. I was totally shocked. And I got a nice QSL card from them. So thank you for listening. I think you can see that a lot's going on in AMSAT-NA. Hopefully will yield exciting results over the next few years. And in the meantime, there are several satellites AMSAT developed that are operational, not to mention a number from AMSAT UK and other organizations, including ARIS on the ISS. So thanks for listening. And do we have time for any questions, Ian, or we're kind of at the end? I know I went over a little bit.
Hi there, it's Barry here. We've got a few minutes for a couple of questions. If anybody has any questions. Any questions? No, I think that was actually a fantastic presentation, Burns. That was brilliant. It tells us what's going on in the States. So could we all show our appreciation, please, in the usual way?
Okay, very good.
Thank you very much indeed for bringing us up to the date on what's happening in AMSAT-NA. It's much appreciated.
Well, sure. And thanks for having me. I enjoyed it.
Thank you very much.
Okay, so long.
Cheers. Hand over to you, Ian.
Okay. Thank you everybody for staying late. I know we ran a little over time. This formally ends the Colloquium program. So all it remains for me to do is to say thank you to everybody for coming. Thank you to the BATC for providing the web stream. Thank you for the RSGB for hosting us. Thank you for Kents Hill providing the venue. And as I say, thank you all for coming. Have a safe trip home, and hopefully we'll see you all next year.